students, today we shall start the 52 number video. Up to 51 number video it was given. So today we start new topics about inverse Laplace transform. The topic is inverse Laplace transform by convolution theorem. The theorem is that L 0 integration 0 to t L of integration 0 to t f1 x f2 t minus x dx this equal to f1s f2s, or if taking L in this side, L inverse f1s f2s equal to integration 0 to t f1x f2 t minus x. So this is our theorem. So this one L inverse, just you have to remember L inverse f1s f2s equal to integration 0 to t f1x f2 t minus x. Now we consider one problem, use convolution theorem to evaluate this. So in this problem, we consider two f1s and f2s. So we consider this, use convolution theorem to evaluate this L inverse s by s square plus 4 whole square. So this expression s square plus 4 whole square, we can write 1 by s square plus 4 into s by s square plus 4. Now if we multiplying these two, we get s by s square plus 4 whole square. So we express in two factors, this into this. So let f1s, this 1 by s square plus 4, and this f2s, this equal to s by s square plus 4. So this factor we consider f1s and this one we consider f2s. Now we taking inverse Laplace transform on both sides. So if we taking inverse Laplace transform on both sides of f1s, then what we get? This can be written as 1 by 2 L inverse 2 by s square plus 2 square. So this is 4 given, 4 means 2 square. We write numerator is 2, here also 1 by 2. 2 cancel, ultimately you get this one. So this is nothing but, this will be a by s square plus a square. This is sin a t. We get this. Because we know this formula, L inverse a by s square plus a square, this is sin a t. By using this formula we get this one. So we get L inverse f of f1s equal to this one, our result. Again we consider this L inverse f2s. We are taking both sides L inverse s by s square plus 4, and this equal to L inverse s by s square plus 2 square. So this is also direct formula, s by s square plus a square. This is cos a t, 2t, a means 2. So I recall the formula, L inverse s by s square plus a square, this is cos a t. So this is our formula. So according to convolution theorem, we have, according to convolution theorem, we have, so what we have, this is our convolution theorem, L inverse this. So L inverse f1s f2s, this one, this equal to integration 0 to t f1x f2 t minus x dx. This is our convolution theorem. Just you have to write this one. Now L inverse f1s means this 1 by s square plus 4, and f2s s by s square plus 4. Integration 0 to t. So first one you consider f1x and second one you consider f2 t minus x. So f1x, just putting t equal to x, we get 1 by 2. This is x, we putting t equal to x, sine twice x, we get this. From this we get sine twice x. And f2 t minus x, we putting t equal to t minus x, cos of 2 t minus x dx. This line is clear? Just using this formula. So we get this one. This one f1 x. f1 is directly write t equal to x, and this is t minus x, putting t equal to t minus x. We get this one. Next, we consider this one, half outside, integration 0 to t sine twice x cos 2t minus twice x dx. We get this one. Now we write 1 by 4. This is 2 given, we write 1 by 4, 0 to t, and here we multiplying by 2. Sine twice x cos 2t minus twice x dx. Just we write 1 by 4, and this is this 2 and this one cancel, ultimately we get half. But we know this formula. What we know? From lower class we know this formula, 2 sine A cos B, this equal to sine A plus B plus sine A minus B. We know this formula. 2 sine A cos B equal to sine A plus B plus sine A minus B. So we assume this is A. This one whole is B. 2 sine A cos B. So this is nothing but our integration 0 to t, and this one 2 sine A cos B plus sine A plus B. So this is twice x plus twice t minus twice x. This is A plus B plus sine A minus B. This is twice x minus b, this minus, this will be plus, minus twice t plus twice x dx. We get this one. Next, 1 by 4 remains same, 0 to t remains same. This will be sine twice t, 2x 2x cancel twice t, and this is sine 2x 2x 4x minus 2t dx. So we get this one. Now we integrate this, twice t is constant, only if we integrate with respect to x means 4x is variable and twice t constant. So we write in this way, 1 by 4 integration 0 to t sine twice t dx plus integration 0 to t sine 4x minus twice t dx. We get this one. So 1 by 4, this twice sine twice t constant, we get twice t, and integration dx means x. We get this one, 0 to t. And suppose this one absent, sine mx, this is constant, suppose this one absent, sine mx, we know this formula, integration sine mx dx equal to minus cos mx by m plus c. We know this formula. So suppose this one is absent, this is sine mx, then this will be minus cos 4x minus twice t by 4. We get this one. This is 0 to t. We get this one. So 1 by 4 remains same, sine twice t, and this is t minus 0. We get this, and this 4, this 4, 1 by 4 cos, putting upper limit, this is minus, putting upper limit 4t minus twice t, and next lower limit cos 4 into 0 minus twice t. We get this one. So 1 by 4 remains same. This is t sine twice t. 1 by 4, 4t minus 2t is cos twice t, and this is 0 cos minus twice t. We get this one. So 1 by 4 t sine twice t, and 1 by 4 cos twice t, cos minus theta means plus cos theta. We get this one because we know this formula, cos minus theta equal to plus cos theta. So this is minus twice t, then this will be plus, and this cancel. We get 1 by 4 t sine twice t, and this cancel, this term is 0. So we get 1 by 4 t sine twice t, and this is our final answer. So by using convolution theorem, we get this is the answer. So dear students, the solution is clear. So I think the solution is clear. So if the solution is clear, then please subscribe my channel and like this video. And if it is difficult, then you have to write in comment box.